so one thing that we can do with any equation, I'm not even going to pick an equation with a variable. I'm going to pick a numerical equation. And in fact, I'm going to put down two of them. Let's say I have 5 plus 6 equals 11. And then, I don't know, 1 plus 2 equals 3. Okay? So the first thing I want you guys to do is make sure that these are correct, that the equality holds, that we're all good. Yeah? Okay, awesome. All right, now, what I can do here is I can take two equations that are different from one another, and if I add them together, I'm going to get a new equation. What I want to see is if the equality holds up there too. Okay, so on this side, I'm going to have 5 plus 6 plus 1 plus 2. It's on the left side. On the right side, I'm going to have 11 plus 3. All right, is this third equation also true? Yes. Okay, so we are allowed to add equations together to get a new equation where equality still holds up. Okay, so that's one thing that's good to know because we're going to use that as a tool in this elimination process. And then the other thing that I want to make sure of is, let's say, in this time we'll just work with one of them. Let's say I multiply this by something. Okay, so I don't know, give me a number. What can I multiply it by? 4. I'm hearing a lot of 4s. Okay, let's say I multiply this by 4. I want to make sure the equality holds up here too. So 4 times 5 is 20. 4 times 6 is 24. And 4 times 11 is 44. Okay, is this also true? Okay, good. All right, so we are allowed to add two equations together to get another equation that is true, and we're allowed to take an equation and multiply it by something to get another equation that is also true. Okay, that's important to know because we're going to be doing this sort of thing with equations in our system when we use elimination. Yeah? Can you factor? Okay, so yeah, could you divide them by something? Absolutely. So let's say I have 5 plus 6 equals 11, and I decide to divide the whole thing by 2, right? 5 divided by 2 is 2.5. 6 divided by 2 is 3. And 11 divided by 2 is 5.5. So that's also true. Good question. Yeah, absolutely. Okay. All right. So this third method that we're going to learn today and final method is called elimination. And the reason why it's called elimination is because in one of the steps, we are going to eliminate one of the two variables, thus reducing our equation down to one variable through addition and or subtraction of equations. Okay, just like what we were doing a second ago. Okay, so let's see how this would work. We have this system over here, 3x plus 6y equals 10, and 3x plus y equals negative 5. Is there a way that I could either add or subtract these equations together so that essentially one of the variables, the coefficient is 0? Because if I have 0 of a variable, that variable disappears or gets eliminated. Yes?
3x plus 6y equals 10 minus 3x plus
Right.
y equals
If I subtract them, 3x minus 3x is 0x. So that means my x variable is going to go away. Now, one thing that you have to be careful of is when you subtract, this subtraction applies to all terms in the equation. Okay, so some people miss that, and then if you have, for example, negative minus negative 5, that becomes a plus 5. So just look out for that. But let's do this one term at a time. 3x minus 3x is 0x. And then 6y minus y, 5y. Yeah? 6y minus, this is like 1y. And then 10 minus negative 5. 15. Okay, well, 0x is just 0, so this is gone. And so we're solving this equation, 5y equals 15. Okay, and to do that, we just need to divide by 5. and we have one of our variables. Okay, so our first step here is essentially we are going to eliminate by adding or subtracting. Then we solve. So we solve 5y equals 15, and we get y equals 3. Are we done? No. When I ask that question, usually the answer is no. Yeah, what do we still have to do? Figure out x, exactly. So in step 3, we have to determine the other variable. Okay, and we actually have two choices when we determine the other variable. I'm going to talk about the second choice in a minute, but the one that we're going to do right now is essentially what we've been doing all along, which is we know that y equals 3, so we're going to plug that value into either equation to figure out what x is. Okay, so let's say I use the first equation, for example, 3x plus 6y equals 10. I know that y equals 3, so this becomes 3x plus 6 times 3 equals 10. Right? And I'll continue that up here. That's 3x plus 18 equals 10. And then I can subtract 18. And I get 3x equals negative 8. Okay, so divide by 3. And here's my x value. X equals negative 8 over 3. No, so if it's a terminating decimal, then you can convert it to decimal. If it's non-terminating, I would prefer that you leave it as a fraction. Okay? All right, so, and now we're done, right? We could verify this, of course. I'm just gonna skip that for now, though, because I don't want today's class to go on for a whole hour and a half. And we've done that several times before. Okay? All right, let's look at the second example. 2x plus 5y equals 15, 4x minus 5y equals negative 1. Is there a way that we could add or subtract these equations together to eliminate a variable? Yeah, what could we do? Yeah, add them. Because essentially, right now the coefficients of y are the same magnitude but different signs. Right? So the idea here is you're either going to be subtracting equations or adding them, and that depends on whether or not the coefficients are completely equal to one another, in which case you'd subtract, right? 3x minus 3x equals 0. Or if they only differ in sign, then you would add them, because 5y plus negative 5y is 0. And you essentially just want to do whatever you need to make that coefficient 0. Okay, so when we do this, we're going to get 2x plus 4x rather is 6x. This is 0, so I'm not even going to put that in there. 15 plus negative 1 is 14. And then I can divide by 6, and I get, this actually reduces to x equals 7 over 3. And that I have to leave as a fraction. Okay, now I have to go and find the other variable, and I can plug it into either equation. I'm just going to do, what did I do last time? I did the first equation last time, so maybe I'll do the second one this time. 4x minus 5y equals negative 1. So I'm going to use this equation and sub in 7 over 3 for x. And this is 4 over 1, right? Times 7 over 3 minus 5y equals negative 1. And that becomes, continue this up here, 28 over 3 minus 5y equals negative 1. So I have to get the 5y or negative 5y by itself first, right? So I think what I'll do is I'll subtract the 28 over 3 from both sides. And then this piece, I have to do some fraction addition subtraction here, right? So I'm just going to do this at the bottom. -1 minus 28 over 3. All right, how do I do that? What do I have to do? Yes? Sorry? Yeah, denominator's the same. So this is now over 1. Okay, so what's my least common denominator? 3, yeah. So I have to essentially multiply this by 3 over 3, right? So it's going to become -3 over 3 minus 28 over 3, and that's -31 over 3. Okay, so what I end up with is -5y equals -31 over 3. And then to solve for y, I have to divide by -5, right? Now, when the other side is a fraction, what I like to do personally is instead of dividing by -5, what else could I do? Yeah. No, because I want to undo this. So what other operation is the same as dividing by -5? No. Multiplying by -1/5. Yeah. Multiplying by -1/5 is the same as dividing by 5. Or dividing by -5, rather. So, and I like to do that because then on the right side, I can do fraction multiplication instead of fraction division. You can still do fraction division if you want. I'm just going to multiply both of these by -1 over 5. And then these cancel. But on this side, I get -31 times -1 is just 31, and 3 times 5 is 15. Okay, if you do it the other way and divide by -5, that's no problem. You just have to remember that when you divide fractions, then you have to multiply by the reciprocal. And the reciprocal of -5 is -1 over 5, right? So it works out to be the same, but it's just kind of a nice trick that I personally like to do. Okay, so there's the solution to our system. Now, who didn't like dealing with all the fractions? Okay, a lot of you. So what I spoke about a few minutes ago is that in step 3, there's 2 options. We can either plug in our answer and get an equation in one variable again to solve for that other variable, or we can actually do the elimination process twice. And I'm going to show you that in the next example. Okay, so you can sort of bypass this mess a little bit if you want, and we'll look at that here. Okay, all right, so here's another guy. 3x minus 4y equals 7, 5x minus 6y equals 8. Okay, can we add or subtract these equations together to eliminate a variable? No, exactly, because the coefficients are different in magnitude and, well, they actually have the same sign, but they're different in magnitude, right? It's not the same number as part of the coefficient. So remember at the beginning of the class I said we could multiply an equation by something to get another equation that's true? This is where we're going to do that here. Okay, so what we have to do is essentially choose one of the 2 variables to have the coefficients either equal to one another or they can differ by a negative sign. Okay, let's suppose we wanted to make the x coefficients the same. What number do you think that coefficient is going to be? Does anyone have like an instinct? Yeah. Yes, 15, exactly. So what you want to do is think to yourself, what could I multiply this equation by so that the 3x becomes 15x? 5, yes. And then what could I multiply this equation by? Exactly, yeah. And essentially what's special about that 15 is it's the least common multiple of 3 and 5. Okay? So when I do that, I'm going to get 15x, and then 5 times -4 is minus 20y equals 5 times 7 is 35. And this one becomes 15x, and then 3 times -6y is minus 18y equals 3 times 8 is 24. Okay, and now I have the x coefficients are the same. So what operation do I need to do to these equations to eliminate x? Yeah, subtraction, exactly. Okay, and again, just be very careful with the double negative. Okay, so 15x minus 15x is 0x. Negative 20y minus negative 18y. What happens there? It becomes a positive, yeah, exactly. And some people like to write that out, like negative 20y minus negative 18y. So this turns into a plus. So negative 20y plus 18y is negative 2y. And then 35 minus 24 is 11. Okay, and then this is gone. So I can solve for y by dividing both sides by negative 2. So that these cancel. And we end up with y equals negative 11 over 2. Or because we're dividing by 2 here, you can write it as negative 5.5. Correct. Okay, so this is how we solve for y. Now, in the last step, we have to figure out what x is. So we actually have two options. We can do what we just did in the first two examples, plug in negative 5.5 for y into either equation and solve for x. Or you can actually do elimination all over again, but this time, instead of eliminating x, you eliminate y. And I actually recommend that a lot of the time, because if you think about a system, right, and the solution, think graphically, the solution is the intersection point. So if you take all of the lines in the world and you have them intersect, the chances that they're actually going to intersect on the coordinates are going to be two whole numbers is actually kind of slim, right? It's much more likely that you're going to get a fraction. And so if you just do elimination again, you don't really have to deal with all of those fraction operations, right? You can just make the coefficients line up, and then you're down to an equation in one variable. So I personally like to do that, but of course you could always sub it if you want to. Okay, so this we did all of this to solve for y. Okay, if we want to solve for x, we need to eliminate y. So if we were to try this all over again, then I'm going to do this here. We're going to solve for y. Okay, we have the system 3x minus 4y, oh yeah, thank you, x, you're right, equals 7. And actually, I'm just going to erase this because I want to give myself a bit more space. I'll make that more clear too. We're going to solve for x. Oh, there we go, that's better. Okay, so our system was 3x minus 4y equals 7, and 5x minus 6y equals 8. Okay, so if I want to solve for x, I need to eliminate y. Yeah, so I'm going to multiply to essentially make these two coefficients the same. Okay, now what's the least common multiple of 4 and 6? 12, right? So what do I need to multiply this so that this is either 12 or negative 12? 3. And what about the second one? Right. So this is going to become 9x and then minus 12y equals 3 times 7 is 21. And then this is going to become 2 times 5x is 10x minus 12y equals 2 times 8 is 16. Okay, and then I can add or subtract these together to get the x variable. What do I have to do in this case? Subtract, right, because the coefficients are the same, right? And just remember to be careful of the fact that the subtraction applies to all three terms, okay? So 9x minus 10x is not x, negative x, or negative 1x. Okay, 12y minus negative 12y becomes 0. And then 21 minus 16 is 5. Okay, so have I solved for x? No, negative x equals 5. What does positive x equal? Right. So there's my x, and here's my y. Okay, now to verify, I am going to sub these values into the original equations, because if you are doing elimination and you have to multiply your equations by a constant, then if you made a mistake in that step and you verify in those equations that you altered, like these two over here or these two up here, you won't pick up on that mistake. Okay, so I'm going to start with the originals, and the originals were 3x minus 4y equals 7. And the other one was 5x minus 6y equals 8. And I'm going to plug in the values negative 5 for x and negative 5.5 for y. Okay, and then I can, so the left side of this first one will be 3 times negative 5 minus 4 times negative 5.5. And the right side is 7. Okay, and then 3 times negative 5 is negative 15. Negative 4 times negative 5.5. Right, 22. Okay, and that is 7 as well, so that's good. And then on this side, same thing, so 5 times negative 5 minus 6 times negative 5.5. And that works out to be negative 25. And this is 6 groups of 5 is 30, plus an extra half group of 6 is 33. And that's 8. And that's what the right side is too. So we're good. Okay? Questions with that? Awesome. Yep.
So when you're trying to find the lowest common multiple to multiply the equations by, does it have to be the lowest common multiple?
No, good question. So, yeah, you don't have to actually do the lowest common multiple. You can pick any common multiple will work as long as they're the same. Yeah. Yep. Okay. So I think today I kind of want to try something different, which is we go through the whole lesson first, and then I get you to do some practice, the in-between ones after, if that's okay. Just because I'm finding some people are doing them in like 1 minute and some people are doing them in 10 minutes. And then the people who do them in 1 minute are kind of sitting around. So I thought that what I'm going to get you to do once we're done, maybe 10, 15 minutes from now, is get you to try all of these examples that are in between. Does that sound good? Okay, so let's look at this one. And in fact, I want to go back to the example that we did at from your homework from substitution as well after we do this one. Okay? Use elimination to solve this linear system. So this doesn't look very pretty because almost all of the constants and or coefficients are fractions. But the nice thing that we just saw is that we can actually multiply equations by a constant and we get another equivalent equation. Could we multiply this first equation by a number that would actually make both of these denominators cancel? What could we multiply this equation by so that the 3 and the 2 both cancel? 6, exactly. We can multiply it by the least common denominator. And I'm actually going to make it 6 over 1 just because we're doing fraction multiplication. And then the 3 and the 2 should cancel. And what could I multiply this equation by? 4, yeah. So 4 is the least common denominator between 2 and 4. So I'll multiply this by 4 over 1. Okay, and this over here is 4 over 1. Okay, now I'm going to do a step in between our final equations. Some of you, probably this is a good idea to take this step. For some of you, though, you can do all of this fraction multiplication and simplify in your head, and if you can do that, that's fine. Okay, so the step that I'm going to do in between is actually write out the product of this. So 6 over 1 times 2 over 3 would be 12 over 3. Okay, and then 6 over 1 times 1 over 2 is 6 over 2, so 6 over 2y. And then 6 over 1 times 4 over 1 is 24 over 1. Okay, and what happens is that all of these fractions now reduce to whole numbers. So this is going to become 12 over 3 is 4x. 6 over 2 is 3, so minus 3y equals 24 over 1 is just 24. Okay, now some people can go directly from here, where we multiply by 6, all the way to here. And if you can do that accurately, consistently, that's totally fine, right? But I do recommend, if you're feeling a little shaky with your fraction skills, to do this step in between. And even if you're not feeling shaky, right, it just reduces the number of careless errors if you slow down a little bit. Okay, now in this case, for the second one, 4 over 1 times 1/2 is 4 over 2, so 4 over 2x. 4 over 1 times 1 over 4 is 4 over 4. 4 over 4y equals, and then 4 over 1 times 5 over 2, so 4 times 5 is 20, over 1 times 2 is 2. Okay, and then the same thing happens. We end up with 4 over 2 is 2x, 4 over 4 is 1y, so plus y, equals, this becomes 10. Because this is addition? Yeah. Okay, there's a couple of side conversations that are happening that are distracting me a bit. So if you could help me out with that, that would be great. Okay, now we can work with these two equations. We're not ready to eliminate yet because none of the coefficients are the same, but we can fairly easily change that. Let's say we want to eliminate x. Yeah, and in fact, you don't actually need to multiply both equations here. You just have to do the second one, right? So if I double this, then I'm still going to have the first one, 4x minus 3y equals 24, but the second one will become 4x plus 2y equals 20. Okay, and then I have to subtract. So 4x minus 4x is 0. Negative 3y minus 2y is negative 5y. And 24 minus 20 is 4. So I can just divide by negative 5. And I get that y equals negative 4 over 5. Okay, now if I wanted to figure out the other variable, which I do because I want to solve the system, we could at this point plug in negative 4y into either of these equations and solve for x, or we could do elimination again, but this time eliminate the other variable, right? So we just eliminated x, now we need to eliminate y. So if I look at these two equations and I want to eliminate y, yeah, so I could multiply this second equation by 3. You could, yeah, so you could multiply it by negative 3, but if you multiply it by 3 and you add them instead of subtract, you're still going to get 0. So some people, by the way, really like to always do addition or always do subtraction. And so when they multiply, they sort of set it up that way. Yes, thank you so much. I typically like just stick with the sign that there is and just do it that way. So I go back and forth between. But if you really like to do addition every time, then do your multiplication step so that you achieve that when you do the elimination, right? So that you change, so that the signs are different, right? Or if you really like subtraction, do that multiplication step so that they are always the same. Okay, so if I'm gonna do elimination, but this time with y, I have to triple this, right? So this is going to become 6x plus 3y equals 30. And then I'll pop the other one down here, 4x minus 3y equals 24. Thank you. Okay, and then when I add these, I'm adding this time because these are different signs. I'm going to get 10x equals 54. And so I'm going to divide by 10, divide by 10. X equals 54 over 10. And then this can be reduced because there's that common factor of 2 to 27 over 5. Okay. So any questions with that so far? All right, so let's go back actually to, I'm just gonna do this at the bottom of the page, to that example from the homework from yesterday, which was, and we just did this at the beginning of class using substitution. I have to rewrite it, let's see. So we had this system that was y equals 1/3 x minus 5. And the second one was x minus y over 5 equals 13. Okay. What could we multiply the first equation by to get rid of that fraction so that we don't have to deal with fractional equations? 3, exactly. So if I multiply this whole thing by 3, I'm going to get 3y equals 1x, or just x, minus 15. And then this one, what do I need to multiply this by to get rid of this denominator? 5, exactly. Okay, so when I do that, I'm going to get 5x, and then this just becomes minus y, equals 5 times 13 is 65. Okay, now, this brings up another issue. There's a slight hiccup in the road that we need to deal with this particular system. What is that? Rearrange, yes, exactly. When you do elimination, you have to line up set up your equations so that like terms are underneath each other, so that they line up vertically. You don't necessarily have to have x, y equals constant. It doesn't have to be of that format, but it does have to sort of follow the same structure, right? So maybe what I'll do is, if I subtract x from both sides, then this equation is going to become negative x plus 3y equals negative 15. And this one is 5x minus y equals 65. Okay, so now I've got the terms that they're lined up underneath each other. Okay, now if I want to use elimination here, what could I do? Yeah, we could multiply the top by 5 to eliminate x, right? I'll just write that underneath. So this is now going to become negative 5x plus 15y equals, what is that? Negative 65, I think? No, 75, right? 15 times 5? Negative 75, I think. Hopefully that's right. And then we need to add. We better get the same answer as before. Oh no. Okay, so this becomes 0x, and then negative y plus 15y is 14y equals 65 plus negative 75 is negative 10. Is this what we got before? Did we get? We did, right? It was negative 5 over 7. Y equals negative 5 over 7. Whew. All right. Sometimes I get a little nervous with this unit because there's lots and lots of steps, and so there's lots of opportunities for careless errors. Okay, so we got y, and then we could do, I'm not going to go through this whole piece. Is that okay? Because we've seen it lots of times, but you could do the same thing with x. Okay? All right. So to finish off today, let's try some applications, and then we'll call it a day. Yeah. Yeah. I do like elimination better. The only thing is that it doesn't always work when solving different types of systems. So if you have, for example, a quadratic system where both equations have an x squared in them, sometimes you can't use elimination, right? And same with if you have a linear quadratic or anything different, right? It sometimes doesn't work. Okay, thank you. So here is our first example. We're going to do the first one, and then we'll set up the next two, and I'll get you guys to finish those off. Okay, so the volume of two acids differ by 1,000 milliliters. The larger volume contained 5.5% acid, and the smaller volume contained 4.5% acid. The total volume of acid in both solutions was 100 milliliters. What was the volume of each solution? Okay. What are the unknowns here? The volume of each solution. And how can we distinguish the two solutions from one another? Yeah? Yeah, size, right? One of them's smaller, one of them's larger. Okay, so in step 1, let the smaller volume be, I don't know, what do you want to make it?
S.
I don't want to make it S because my S's look like 5s. What's that? A. All right, sounds good. And let the larger volume be B. Or you could make it L and be little big, something like that. Yeah. Okay. There we go. Okay, and do you guys know a little bit about acidic solutions, how they have to be diluted? Yeah, what would happen if you stuck your hand in a pure acid solution?
Bye-bye hand.
Yes, you would take it out and your hand would be gone. That's a bit of an exaggeration, but yeah, it wouldn't be a good idea. Yeah, so acid, pure acid is very strong. We usually have to dilute it significantly so that, you know, well, depends what you're using it for, right? If you're using it for corrosion, I suppose you'd want it to be really strong, but then you wouldn't stick your hand in it. Yeah, okay. Now, we need to come up with two equations that relate these two together. Do you guys see any totals? Yes, 100 milliliters is a total. What about the 1,000? Is it a total? Yeah, it's a difference. Yes. So in step 2, the volumes differ by 1,000, right? Differ means difference, subtraction. So when you take this larger and you subtract the smaller, you should get 1,000 milliliters. And that's B minus A. Okay? And then what about the 100 milliliters? How are we going to put that into an equation for a total? But remember volume A, like if you imagine this mug, right? Only 4.4% of it, if it's the smaller volume, is acid. The rest is water. So it's for the smaller volume, it's 4.4% of the volume. Yeah, so not 4.5. as a decimal, a percent would be 0.045, right? B. No. A. You know what I'm going to do? Shh. Since the B term comes first and the A term comes second, I'm actually going to do the same thing here. So my larger volume is 5.5% acid. So I'll make this 0.055B plus 0.045A equals 100. Because then, just like we talked about a few minutes ago, B terms line up, A terms line up, numbers line up. Okay? So now we have to solve this thing, right? And we today are going to solve using elimination. This actually would be one of the few circumstances where I actually might solve this one using substitution, just because of the decimal values and the coefficients. But actually, it's not terribly hard. It's actually easier to make the coefficients the same, like change the first equation, than change the second one. Because let's say I want the B values to be the same, or coefficients, I could just multiply this by 0.055, and then they're the same, right? So some people think I gotta move away from the decimals, but that's not always true. Sometimes it's easier, right? This is step 3. So I'm gonna take this guy and multiply it by 0.0, whoops, too many zeros. 0.055, or you could do 0.045. And that's B minus A equals 100. 1,000, sorry, 1,000. Okay, so that becomes this. And I think this times 1,000 is 55. Yeah. Okay. And then I'll write the second one underneath. Okay, and then when I subtract, this goes away. Ah, hold on. Okay, so the first term goes away, and then negative 0.055 minus 0.045. You could certainly like do that. I just did it with my last class on a calculator. So 0.055, I'm going to make that negative 0.055 minus 0.045 equals negative 0.1. A equals 55 minus 100 is negative 45. So when I divide by negative 0.1, I should get that A is equal to 450, and that's in milliliters. Okay, well, if that's the smaller volume, then what's the bigger volume going to be? 550? How much do they differ by? 1,000, yes. So B would have to be 1,450 milliliters. Yes?
A be 4,500?
I don't think so, because 45 divided by 1/10.
Oh, 0.1.
Yeah, yeah.
I thought that was not.
You missed the decimal, yeah.
Yeah.
Yeah, okay. Any questions with that? Okay, I actually think I'm gonna stop there and let you guys try and work on these next ones. And also, please go back and look at these examples as well. This guy we didn't do, and then this one at the bottom with the fractions. And also, please take a look at your homework from today.